Data confirms green status across the board.
Excellent. Let's move to the next section.
Workers aged 22 to 25 move precisely according to procedure, every action aligning perfectly with predefined standards.
All parameters are within limits. Every connection is tightened to correct torque. Every surface is clean with no sign of abnormality.
From the outside, this is a state that anyone could call perfect. But in the eyes of the male engineer, that perfection does not bring reassurance, but instead triggers a silent doubt. No one says it, but everyone understands that perfection in aircraft engineering is never accepted simply.
And the question begins to form right in that silent moment.
Why, when everything seems perfect, do engineers never trust it?
In normal operation, each aircraft is designed to reach near absolute precision in every smallest detail.
Every system has standards, and those standards define what is safe and acceptable.
Everything is stabilizing now. We're within the theoretical operating range.
Excellent. Let's maintain current levels.
Workers perform each step according to checklist, without missing even the smallest item.
In this environment, stability and repetition are mandatory to ensure every flight maintains consistent safety. A system operating correctly means no observable error at the current moment. Every process is built on the assumption that if everything is correct, the aircraft will operate safely.
This is the foundation of aviation engineering, where everything is measured, controlled, and continuously verified.
But this very foundation contains a paradox that not everyone realizes.
Because when everything is correct, it does not mean everything is truly safe. The male engineer begins to question what is not in the data, the things that numbers cannot fully capture.
The female engineer looks back at operational history and realizes that many failures occurred even when all indicators were previously completely normal.
Workers have witnessed situations where a small detail that seemed insignificant led to major consequences.
Perfection on paper does not reflect the changing reality of actual operating environments.
Temperature, pressure, vibration, and time create changes that are not always immediately recorded. A system can be perfect at inspection time, but begin to degrade immediately afterward without clear signs.
If everything is perfect, why do failures still occur?
If data shows no fault, then where does the fault come from?
These questions force engineers to look deeper into the nature of perfection.
In aircraft engineering, perfection is not a real state, but only a temporary assumption.
Every system has limits, and every measurement has error, no matter how small.
Workers understand that even durable metal is affected by fatigue, temperature, and time.
A detail with no current fault does not mean it will not become a weakness later.
Perfection is therefore not proof of safety, but a moment before a problem is detected.
Engineers do not trust perfection because they understand every system is moving toward its limits over time.
Instead of trusting the current state, they assume something unseen still exists. This is the core principle of engineering mindset in aviation.
It is not about seeking perfection, but about searching for potential failure.
Ensure all access panels are secured before sign-off.
And that very doubt is what keeps the system safe. The male engineer compares two perspectives, one trusting current data and one questioning the system's future.
In many fields, perfection is the goal. But in aviation, it is the starting point of doubt.
This difference creates a completely different mindset from other industries. The more perfect a system appears, the more engineers must inspect it. Not because they distrust engineering, but because they understand its limits.
Perfection is what most easily creates the illusion of safety.
This makes aviation engineering a field that never accepts complacency.
And this distrust of perfection creates true reliability.
I've logged the final checks. We need to monitor the temperature flux closely.
Agreed, especially during the next phase inspection.
Workers leave the area, but the control process continues within the system.
No one declares the aircraft perfect, only that it is safe at this moment.
At this scale, the engineering is sound, yet we rely on a leap of faith for orbital velocity.
Faith is just control we haven't mapped yet. We must understand that boundary.
In aircraft engineering, there is no endpoint of perfection, only a continuous process of detecting and reducing risk.
Engineers never trust perfection because they understand safety is not a state, but a journey.
Everything appears perfect, yet we must question the vibration results on the mount. The telemetry showed minor fluctuations. Let's run the diagnostic again.
And that is what allows every flight to leave the ground with the highest possible level of safety.